I just spent the last few minutes doing the final assembly for the power pickup on these all-wheel pickups, and I've found a system that's fairly simple, and I thought I would share that with you guys. So if some of you want to get these parts, either print them or buy them, you can do this wiring yourself. It's fairly straightforward. The wire that I use is from Dependable Spring Company, and you get that on eBay, and it's custom wire, custom springs and wire forms. It's wire number C17200. I get 15 feet at a time. It's 0.016 beryllium copper spring wire, and it's silver plated, so that gives it a corrosion resistance plating. You can form it. You can't reform it. It once it's set, it likes to stay there, and if you try to monkey with it too much, it'll fracture. But the trick I've learned, and it's like I've been doing this for years, literally, and I tried to come up with something, came up with something. All I need is a straight wire with a loop in the middle, and that wire needs to be approximately 44 millimeters in length to straddle the 2-axle. The 3-axle is a different story, okay? We'll get to that. But the loop in the middle is a 2 millimeter circle. It's not big, okay? And you can find 2 millimeters if you have these forming pliers. I got these like at a hobby store for jewelry makers, and those are like a pair of cones. And you clamp the wire and you form the wire around it, and it makes a nice circle. At any rate, what I did was I marked out the 22 millimeters with the wire. I held it with my thumb like that. I grab it with these guys and I form a loop, not moving this piece, not shortening or lengthening that piece. I just form that loop, and then I straighten them out flat. I lay it back down and I cut it at 22. No scrap. Very simple install. It just slides right in under there. You got to flip it to make sure you got the loop on the inside, because that's where these screws are going to go. And then you put the screws in. These are number 256 screws, about 3/16 long. I use the Allen head because I have a nice driver set that will give me a good grip on the part, and I can set it in there and I can get it driven in nicely. And you just snug them. You don't even tighten them, because you want a spring load. So anytime it goes above that pivot point, there's a little bit of spring pushing it back down, and it works like a charm. And there's no binding. It's just resting on the axle like this, so it just spins fine. There's a tiniest bit of resistance. It doesn't free spin like it used to, but it's not going to. It's got a wire rubbing on it, but it's okay. You're picking up now. So you got power pickup. Next thing I have to do is solder that wire in onto that and push it. I'm going to probably push it through the hole first and then solder it and then pull it back. But I'm going to solder that, and what I do is I get the wire tinned and I just barely touch the solder. My iron is hot, so it's going to go right to it and stop. You don't want to overheat the wire, and you don't want to melt any plastic. It's a little tricky to assemble it with the wire on, but you can do it. I've taken it all apart and done it that way. But I'm finding this assembly so far has been pretty simple. I'm really ready. Oh, my last part's done. I got the part now. I put the motor down. Now I'm going to put in the power distribution panel. I got the part to hold that, and I will be pretty ready to wire and put the couplers on and test this thing out. So that's how it works. You just print a part while you're building something else, you see. I got to use a scraper. He's not cooled off enough. This printer is working pretty darn good for me so far. I've got Clipper on a Pi, and I have to say it is amazing. Clipper is amazing. All right, gang, later.